Falcon 1 Test. These were the do-or-die missions that started it all. The first 3 flights of the small, scrappy Falcon 1 rocket all ended in heartbreaking failures, from engine fires to stage collisions. With enough money for only one more attempt, Flight 4 in 2008 was a make-or-break moment for the company. It successfully reached orbit, becoming the first privately developed liquid-fueled rocket to do so. This single success saved the company and proved its fundamental design philosophy could work. Falcon 9 Maiden flight. Before it could carry any valuable payloads, the Falcon 9 itself had to be proven. On June 4, 2010, the first ever Falcon 9 rocket successfully launched from Cape Canaveral on its maiden flight. Its payload was a boilerplate test version of the Dragon capsule, designed simply to simulate the mass and aerodynamics of the real thing. The mission was a resounding success, with the 9-engine first stage and the single-engine second stage performing perfectly. This single flight was a monumental milestone, validating the rocket's fundamental design and giving NASA the confidence to proceed with the far more complex Dragon demonstration missions. COTS Demo. After proving the rocket worked, SpaceX had to prove its capsule could function as a true spacecraft. This was done in 2 critical steps. The first was COTS Demo 1 in December 2010, which saw the first real Dragon capsule successfully reach orbit, circle the Earth twice, and perform a flawless re-entry and splashdown, proving its fundamental spaceflight and recovery capabilities. The culmination of the program was COTS Demo 2+ in May 2012. This mission saw a Dragon capsule fly all the way to the International Space Station, where it was successfully captured by the robotic arm and berthed, a historic first for any private company. Reusability development flights. This was the program that changed rocketry forever. The journey to reusability began with Grasshopper, a bizarre-looking, low-altitude flying testbed in Texas whose sole purpose was to prove a rocket could perform a vertical propulsive landing. After its successful hops, the program moved to the more advanced F9R dev vehicles. These were full-scale Falcon 9 first stages that conducted much higher altitude test flights, allowing engineers to perfect the use of grid fins and complex engine burns for a controlled descent. This iterative, hardware-rich test campaign provided the crucial data that made the eventual operational landings of Falcon 9 boosters possible. CRS. These are the workhorse logistics missions that have become the lifeline of the International Space Station. Under the Commercial Resupply Services contract with NASA, SpaceX has flown dozens of missions with its Dragon and later Cargo Dragon 2 capsules. These flights deliver thousands of pounds of critical supplies and science experiments to the ISS. Crucially, the Dragon is the only cargo vehicle capable of returning a large amount of scientific data and hardware back to Earth. Commercial Crew Test. Before NASA would put its astronauts on a Falcon 9, SpaceX had to complete a rigorous series of test missions. This began with a pad abort test, followed by the uncrewed Demo 1 mission, which flew an autonomous Crew Dragon to the ISS and back. After a dramatic in-flight abort test, which proved the capsule's escape system, the campaign culminated in the crewed Demo 2 flight, where astronauts Bob Behnken and Doug Hurley carried out SpaceX's first crewed orbital test mission, successfully validating the entire system for operational use. Crew Dragon missions for NASA. These are the operational Crew Dragon missions that began after Demo 2 restored U.S. human spaceflight capability from American soil. Following the successful test campaign, the operational crew missions began with Crew 1 in 2020. Flown on the human-rated Falcon 9 and Crew Dragon, these missions typically carry 4 astronauts to the ISS for long-duration stays and established routine U.S.-launched crew rotation flights. Private Crew Dragon. Beyond its NASA contract, SpaceX has also used the Crew Dragon to open up a new era of private human spaceflight. This began with Inspiration 4, the first all-civilian mission to orbit the Earth. It has been followed by the Axiom Space missions, which are private astronaut flights to the ISS, and the ambitious Polaris program, a series of missions designed to test new technologies like the first-ever commercial spacewalk. Starlink Deployment. This is, by an overwhelming margin, the most frequent type of SpaceX mission. These launches are dedicated to building out SpaceX's own Starlink satellite internet constellation. A typical mission carries a stack of dozens of Starlink satellites to low Earth orbit. The sheer number and rapid cadence of these launches are made possible only by the high reusability of the Falcon 9 rocket, and they have single-handedly made SpaceX the world's largest satellite operator. Smallsat Rideshare. SpaceX has used the Falcon 9 to become a space bus for the small satellite industry. The transporter and bandwagon missions are dedicated rideshare flights where dozens of small satellites from many different companies and universities are packed onto a single rocket. By offering a regular, scheduled flight to orbit at a low price, these missions have democratized access to space for a huge number of new players. Falcon Heavy. These missions are reserved for the heaviest and most demanding payloads. The Falcon Heavy, essentially 3 Falcon 9 cores strapped together, is one of the most powerful rockets in the world. It is used to launch massive geostationary communications satellites, critical national security payloads for the U.S. Space Force and the NRO, and major scientific probes such as Europa Clipper to Jupiter and Psyche to the main asteroid belt. Government and national security. Beyond its NASA contracts, SpaceX has become a critical launch provider for the U.S. government. It regularly launches GPS satellites for the Space Force, spy satellites for the National Reconnaissance Office, and constellations for the Space Development Agency. Winning these high-security contracts was a major milestone, breaking a long-standing monopoly and proving the Falcon 9's reliability for the nation's most sensitive assets. Starshield. This is a distinct business line that leverages the Starlink satellite platform for national security purposes. Starshield missions deploy satellites that use the same basic bus and technology as Starlink, but are modified with specialized payloads for government clients. These missions are designed to provide secure communications, Earth observation, and other sensing capabilities, creating a resilient, high-volume satellite constellation specifically for government use. NASA Science. Beyond human spaceflight, SpaceX's rockets have become the go-to launch vehicles for some of NASA's most important scientific endeavors. The powerful Falcon Heavy is used to send deep space probes like the Europa Clipper on high-energy trajectories to the outer planets. The workhorse Falcon 9 has launched critical Earth science missions like SWOT to study ocean topography, and SpaceX's Falcon Heavy has been selected to launch the Nancy Grace Roman Space Telescope, making SpaceX a key partner in NASA's broader science portfolio. Commercial satellite launch. This is the core business that made SpaceX a global powerhouse. Outside of its Starlink and government contracts, SpaceX launches large communications and Earth observation satellites for commercial companies from all over the world. The Falcon 9's combination of low cost and high reliability completely disrupted the global launch market, capturing the vast majority of commercial launch contracts from its international competitors. Lunar Missions. SpaceX rockets are now the primary launch vehicle for America's new commercial lunar industry. The Falcon 9 has launched a series of robotic lunar landers for private companies under NASA's CLPS program, including Intuitive Machines IM-1, the first private spacecraft to ever land on the Moon. It has also launched lunar orbiters like South Korea's Danuri, making it the go-to rocket for the new era of robotic lunar exploration. Starhopper. The spiritual successor to Grasshopper, Starhopper was the first rudimentary flying prototype for Starship, a strange, squat vehicle often nicknamed the Flying Water Tower. Its purpose was to be a low-altitude testbed for the massive new methane-powered Raptor engine and the radical landing profile envisioned for a much larger vehicle. In 2019, it completed a 20-meter untethered hop and later a 150-meter hop and landing, serving as an early proof of concept for the Raptor engine and the basic flight profile of the Starship program. Starship Test. These are the ongoing, iterative test flights of SpaceX's next-generation, fully reusable launch system. Conducted from their Starbase facility in Texas, these missions are designed to test the limits of the massive Super Heavy booster and the Starship upper stage. The primary goal of these flights is to prove that both stages can successfully fly, separate, and perform a controlled return and landing, a necessary step before the vehicle can be certified for operational use. Future Mars and deep space plans. The ultimate goal of SpaceX is defined by missions that have not yet flown. The entire Starship program is designed with the singular purpose of making humanity a multi-planetary species. The first operational missions will be to deploy the next generation of Starlink satellites and to serve as the Starship HLS, the vehicle that will land NASA's Artemis astronauts on the Moon. But the final goal remains Mars, to launch a continuous flotilla of starships to build a self-sustaining city on the Red Planet. Thanks for watching. Do you think SpaceX will reach Mars in our lifetime? Let me know in the comments down below. Also, please remember to like and subscribe if you enjoyed this video.